Hello everyone, welcome back to Rare Chem Official. Today we are going to discuss about valence shell electron pair theory. It was proposed by Sidgwick and Powell, and later it was further developed by Nicolom and Gillespie according to VSEPR theory. The shape of molecule depends on the number of electron pairs in the valence shell, bond pairs and non-bond pairs of the central atom. CH3 minus ion. Z means hybridization equals to 1 by 2 into 4 valence electrons present in carbon, and 1 is the charge, 3 is the monovalent atom surrounded by carbon, or 3 equals to 4 sp3 hybridization. 4 is the Z value minus the surrounded atoms are 3. 4 minus 3 equals to 1. Lone pairs equals to 1 lone pair. Here 3 lone pairs and 1 bond pair. 3 bond one bond pair, 1 lone pair and 3 bond pairs. Bond pairs means which participates in the chemical bond. These are the non-bonded or lone pair of electrons not participating in chemical bond. The geometry depends on bond pairs and lone pairs. If the molecule has 0 lone pairs, the geometry equals to shape. Example, SO3 half into 6 valence electrons present in sulfur. Here SO3 molecule, no charge means no positive and no negative charge present, no monovalent atoms present. So carbon in sulfur valence electrons are 6. 1 by 2 into 6 equals to 3 sp2 hybridization. Lone pairs, this Z value equals to lone pair and bond pairs. Lone pairs equals to the Z value minus Z value here 3 minus surrounded atoms 3. 3 minus 3 equals to 0. In SO3 molecule 0 lone pairs. 0 lone pairs, what if the molecule has 0 lone pairs? The geometry equals to shape. Here the shape geometry is trigonal planar, the shape also trigonal planar. If the molecule has lone pairs, the geometry is not equals to shape. If take SO2 molecule half into 6 valence electrons present in sulfur. In SO2 molecule no monovalent atoms, no charge present. So 6 valence electrons present in sulfur. 1 by 2 into 6 equals to 3. These 3 included both lone pair and both bond pair. 3 is the Z value minus surrounded atoms 2 equals to 1. Here the 1 is the lone pair. 1 lone pair, 2 bond pairs. In bond pair, lone pair and bond pair, repulsions more than bond pair and bond pair, and the bond angle is greater than 120 between lone pair and bond pair. And here the bond pair repulsions are less, and the bond angle is less than 120. If observe, lone pair repulsions are greater than lone pair, then bond pair. So the bond angle is greater than 120 in between bond pair and lone pair, and the bond angle is less than 120 in between bond pair and bond pair. The geometry is trigonal planar. In here one lone pair is present, so shape is bent or V or angular shape. Lone pair has more repulsions. Electron pairs repel each other and tend to stay away. If observe SO2, here one lone pair and 2 bond pairs are present. If repulsions between one bond pair and lone pair, it moves away from each other, means like this. And if repulsions between this lone pair and this bond pair, the repulsions occur, means this both are stay away from each other to come like this. If Z is hybridization. If Z value is 2, the bond pairs are, if bond pairs are 2, lone pairs 0, the geometry is linear and shape also linear, because the lone pairs are no lone pairs are present. The shape is equals to geometry. The hybridization is sp. In Z value is 2, if the bond pair is one lone pair is 1, that it is not means one bond pair means not participate. 3 bond pair, if z value is 3 and 3 bond pairs, 0 lone pairs, the geometry is trigonal planar, the shape also trigonal planar because 0 lone pairs, and the hybridization is sp2. If the angle between these atoms is 120 degree, if the z value is 3, if bond pairs 2, 1 lone pairs are present in the molecule, the geometry is trigonal planar and the shape is bent or V or angular shape. The hybridization is sp2. Here 1 lone pair is present. If observe, lone pair has more repulsions than lone pair bond pair, then bond pair. Here one lone pair, one bond pair. The bond angle between lone pair and bond pair is greater than 120, and the bond pair, the bond angle is less than 120 because already we discussed lone pair has more repulsions than lone pair bond pair, and lone pair bond pair has more repulsions than bond pair. So less than 120 degree angle present in bond pair and bond pair. If the Z value is 3 and 1 bond pair and 2 lone pairs are present in the molecule, the geometry is trigonal planar, the shape is linear, the hybridization is sp2. If observe 1 bond pair and 2 lone pairs, the bond between these 2 lone pairs has greater than 120 degree, and bond pair lone pair in between the bond angle is greater than less than 120. Already we discussed, right? Lone pair has more repulsions than lone pair and bond pair. So here greater than 120 bond angle, here less than 120 bond angle, the shape is linear, the hybridization is sp2. If the value is z equals to 4, the bond pairs are 4, 0 lone pairs, the geometry is tetrahedral, shape also tetrahedral because of lone pairs, no lone pairs, and hybridization is sp3. If the z value is 4, the bond pairs are 3 and 1 lone pair are present in the molecule, the geometry is tetrahedral, here 1 lone pair is present, the shape is pyramidal, the hybridization is sp3. And the bond angle between lone pair and bond pair, the angle is greater than 109 degree 28 minutes, and the bond angle between bond pair is less than 108 degree 28 minutes because lone pair bond pair has more repulsions than bond pair, so it has less than 109 degree 28 minutes. The shape is pyramidal. If the Z value is 4, the bond pairs are 2. If the lone pairs are 2 present in the molecule, the geometry is tetrahedral. The shape is bent RV shape. The hybridization is sp3. Here 2 lone pairs and 2 bond pairs. In between 2 lone pairs, the bond angle is greater than 109 degree 28 minutes. It is less than 109 degree 28 minutes in between bond pair and bond pair because of lone pair has more repulsions than bond pair. The shape is bent or V shape. If the Z value is 5, the bond pairs are 5. If 0 lone pairs, the geometry is trigonal bipyramidal, shape also trigonal bipyramidal because of 0 lone pairs. The hybridization is sp3d, and in these are the axial positions, these are the equatorial positions. If molecule has more electronegativity atoms present, it occupies axial position. According to Benz rule, lone pairs will occupy equatorial position, electronegativity atoms will occupy axial position. If take xenon O3F2, the Z value is equals to 1 by 2 into 8 valence electrons present in xenon and 2 monovalent atoms and no charge is present, so it is equals to 5. The hybridization is sp3d. Lone pairs equals to 5, the surrounded atoms 3 plus 2 is equals to 5 is 0. Here 0 lone pairs, and here carbon, nitrogen, oxygen. Fluorine is more electronegativity atom, Then oxygen. Here we discussed electronegativity atoms will occupy axial positions. So fluorine occupies axial positions, and if the value is Z equals to 5, the bond pairs are 4 and one lone pair is present in the molecule. The geometry is trigonal bipyramidal, and the shape is seesaw because of one lone pair. The hybridization is sp3d. Here one lone pair, actually lone pairs will occupy only axial equatorial position. In if if Z value is 5, the bond pairs are 2, two lone pairs are present in the molecule. The geometry is trigonal bipyramidal, and the shape is T shape. The hybridization is sp3d. If the value is Z equals to 5, the bond pairs if the bond pairs are 2, lone pairs are 3 present in the molecule. The geometry is trigonal bipyramidal, shape is linear. The hybridization is sp3d. If take xenon F2 off into 8 valence electrons present in the xenon atom, and 2 monovalent atoms, no charge is present in this xenon F2, and it is equals to 5. 5 minus surrounded atoms equals to 3. 2 minus 5 minus 2 equals to 3. It is equals 3 equals to 3 lone pairs, and here 2 bond pairs and 3 lone pairs. Lone pairs will occupy always equatorial position. More electronegativity atoms will occupy only axial position. The shape is linear. The geometry is sp3d. If the Z value is 5, one bonded, 4 lone pairs. The one bonded means it is not a form, means it is not exist like that. 4 bond pairs, 4 lone pairs, one bond pair means it is not formed. 6, if Z value is 6 and 6 bond pairs, 0 lone pairs, the shape geometry is octahedral, and shape also octahedral because of lone pairs, 0 lone pairs, and the shape hybridization is sp3d2, and 6, if Z value is 6, the 5 bond pairs and 1 lone pair is present in the molecule. The geometry is octahedral. The shape is square pyramidal. The geometry is sp3d2, and if the molecule has Z equals to 6, the bond pairs and bond pairs force, 2 lone pairs are present in the molecule. The geometry is octahedral. The shape is square planar. The geometry hybridization is sp3d2. If the molecule has Z equals to 7, the bond pairs are 7, 0 lone pairs. The geometry is pentagonal bipyramidal. Shape also pentagonal bipyramidal because of 0 lone pairs, and hybridization is sp3d2. Thank you for watching.